Yes, students. In this session, we learn about trigonometric identities and the problems related to these identities. Before starting the portion, I would like to have a few words with you. As you know, this is one of the important, at the same time, difficult topics of trigonometry. And when you deal with the problems related to these identities, I think you would have noticed that almost all that we learned earlier in mathematics is used here. We need to use many mathematical concepts that we have already learned. In certain cases, we need to use the algebraic identities. In certain cases, we need to use the basic laws of addition, subtraction of fractions. And also, we need to make suitable substitutions in order to arrive into the solution as suggested in the questions. That means you need to be careful and you need to be intelligent also. That is, you need to by heart all the identities and you should be very keen to use appropriate changes and also appropriate substitutions in accordance with the question and also in accordance with the conclusion or the proof that we need to make in that particular question. In my attempt, I would like to deal with almost everything related to these situations. And I think by listening to my classes, you will have a wider vision on this session, a wider and deeper knowledge of these identities and its uses and usages would enable you to solve these problems, the problems related to trigonometric identities, and also using these problems, you need to prove something. These all can be done easily without much difficulties by listening to my classes. In any right triangle, base square plus altitude square is equal to hypotenuse square, or the square of the longest side is equal to sum of squares of other two sides. In this triangle, right angled at B, AC is the longest side, which is the hypotenuse. AC square is equal to sum of squares of AB and BC. AB square plus BC square equals AC square. Let me divide the equation by AC square. We get AB square by AC square plus BC square by AC square equals AC square by AC square. For the acute angle A, BC is the opposite side, AB is the adjacent side, and AC hypotenuse. Therefore, AB by AC is adjacent by hypotenuse, that is cos. AB square by AC square is cos square A. Here we consider angle A. Plus opposite by hypotenuse is sine. Here squares sine square A equals AC square by AC square is 1. This is one of the important trigonometric identities. Cos square plus sine square A. Cos square A plus sine square A is equal to 1. From this, we can derive a few more equations. Cos square A is equal to 1 minus sine square A. Similarly, cos A is equal to root of 1 minus sine square A. Sine square A is equal to 1 minus cos square A, and sin A is equal to root of 1 minus cos square A. In the same way, when you divide the equation by AB square, you get 1 plus tan square A equals sec square A. AB square by AB square is 1. BC is opposite side, opposite by adjacent is tan square A, and hypotenuse by adjacent side AC by AB is sec. Here square is sec square. From this equation, we can find that sec A is equal to root of 1 plus tan square A. Tan square A is equal to sec square A minus 1, and tan A equals root of sec square A minus 1, and sec square A minus tan square A equals 1. And if you divide the equation by BC square, you get 1 plus cot square A is equal to cosec square A. BC square by BC square 1, AB square adjacent by opposite, cot, hypotenuse by opposite, cosec. 1 plus cot square A equals cosec square A. That is, cosec A is equal to root of 1 plus cot square A. Cot square A is equal to cosec square A minus 1, and cot A is equal to root of cosec square A minus 1. And finally, cosec square A minus cot square A equals 1. Dear students, in this session, I am not going to attempt problems related to trigonometric identities, but here I would like to introduce certain views or certain methods which reveal you how to interact with these problems. In the following sessions, we will have a detailed study of solving the problems, and also we will look into the problems which are even difficult, which are very important from the examination point of view. And when I explain these problems, each step, Everything will be explained in detail. Now let's see some of the ways in which you need to deal with the identities. Let's see some of them. See, there is an expression like this: sec A plus tan A. In certain cases, you need to change this expression as a fraction. Here, when you see sec and tan A, one thing should come into your memory, that these two can be expressed as fractions having same denominators. Ck is 1 by cos A and tan A equals sin A by cos A, which can be expressed as 1 plus sin A by cos A. Similarly, cosec A plus cot A can also be expressed as two fractions having same denominators. Cosec A is 1 by sin A. Cot A is cos A by sin A, which can be simplified as 1 plus cos A by sin A. Again, if this is the expression, you can change it into this form. First, this can be expressed as two fractions by splitting the sum by taking same denominators and having different numerators. In this way, you can split this fraction. Again, this can be expressed as this. The same thing can also be done here. This is one way of approaching this problem. Let me give you another example. Tan A plus cot A. Tan A can be expressed as sin A by cos A plus cos A by sin A is cot A. Same as you add fractions having different denominators, or same as you add unlike fractions, we can add these two expressions. LCM of the denominators is sin A cos A. As you add fractions, divide the LCM by the first denominator, you get sin A. This is multiplied by the numerator, sin A into sin A, sin square A, plus divide the LCM by the second denominator, you get cos A. This cos A is multiplied by the numerator of the second fraction. You get cos A into cos A, cos square A. This is equal to 1 by sin A cos A. You know, sin square A plus cos square A is 1. This can be expressed as 1 by sin A into 1 by cos A. Again, can be expressed as 1 by sin A is cosec A into sec A. 1 by cos A is sec A. Let's meet in the next session.